Let's now talk about modules. We will use modules to create our architecture so we can put our code in many different files and many different packages, and so we can create our own libraries. First example, which we will create for our modules, will be to import third-party library from the internet to our project. Let's create new package and new directory for our new project. Inside of our project, we will create new Go file, main.go, and we will create another file, go.mod. Inside of our main file, we will write our code, and inside of our go.mod file, we will define our modules. Inside of our go.mod file, we have three different sectors. In module sector, we want to specify 0 module, which will be our starting point for all modules which we will create. This will be 0 module in my project. Then, in require sector, we will specify a library which we want to use, and then we will specify specific tag in which we want to declare specific version for that library. In this case, I want to use Logrus library, and this library we can use for our logs. How we can know which version we want to use for this library? We can go on GitHub and open this library so we can see all tags which are in release list. In Google search, we will type name of our library. Then we will open that library on GitHub. Now we opened public repository of this library on GitHub. We can see that this repository has 9 branches and 49 releases. Now we want to open tab of our releases. Here we can see the latest release and specific tag for that release. We will use this tag and we will write that tag to our required module. So we will use v1.4.2 because this is the latest release. We can close our browser and type that tag in our go.mod file. Now we finished our require sector. In Go sector, we will only specify version of Go language which we will use. For this case, I will use 1.13. And now we finished writing of our go.mod file. We will save this file, and after that we will open our main file so we can write our code. Inside of our main file, we will declare our import section. In import section, we will specify library which we want to use, in this case Logrus, and we will type alias log for that library. We want to access that library inside of our main function, and we want to call info function. We will save our main file. Then we will open our terminal and we will enter into our project. If you type Ctrl L, you can clear your terminal. When we run our main file, we will get output of our log. As you can see, we got output from our main function. So what happened here? If you see inside of our project, we have a new file. That file is go.sum. Let's open that file. Data in this file is generated automatically, which means we don't write this file. Our modules inside of our language do that for us. In this file, we can see all libraries with their tags and all dependencies which we use so we can call functions from that libraries. This is the only information about that libraries. But real question is where we store that libraries. We have specific place and let's find that place. For this, we will open our internal Linux terminal. We want to go on specific location, and that location is inside of this directory, our language, put all our mods which we will use inside of our projects. If we list all files inside of our mod directory, we can see this. We can see directories in which we will find libraries as our third-party libraries. So that's the place where our language put our modules which we import as third party. When we want to run our program, our language is taking these libraries from this place and run them as part of our code inside of our project. Now we can close our terminal. This is the first way how we can import our modules. Second way would be that we can create vendor directory. For that, we will use our go-mod core function. Inside of our project, we will type go-mod and then we will use vendor function. We will execute this command. Now, inside of our project, we can see new directory vendor. Let's now close our terminal and open our vendor directory. So now, inside of our vendor directory, we can see third-party libraries and dependencies which we will use inside of our project. Our main function, instead of using our modules from our system in go pkg mod directory, our main file will use libraries from our vendor directory, which means that now we have third-party libraries and dependencies inside of our project. In that case, we are not depending on our system. All we need, we have inside of our project. That is the purpose of our go mod vendor command, so we can be independent of our system. Let's now create new project in which we will separate our specific code in different packages and in different files. Inside of our new project, first we will create new go.mod file. In this file, our zero mode will be this. Our required sector will be also Logrus library. And we will specify version of Golang which we will use. Let's save this file and close it. We will create new directory model. Inside of our model directory, we will create new directory person. Inside of our person directory, we will create new Go file, and that file will be person.go. Inside of this file, first we will declare our package. Our file belongs to our person directory, which means that for package we will specify person package. We will create new structure person. Next, it's not necessary, but in this case, we will create new custom constructor. That constructor will be new function, and inside of this function, we want to return new person structure with pointer, where values of this new object will be values which we will pass to our new function. We can save our file and close it. We want to create function which will be connected to our person structure. That new function we will create in another file inside of person package. Inside of this file, we will also declare person package. We want to create setName and getName functions which will be connected to our person structure. we created this kind of functions in previous sectors. If we create functions connected to specific structure in another file, where we don't have whole declaration of our structure, these two files must belong to same package. So in this case, we have person file and we have also person name file in which we have two functions. These two files belong to person package. We will save our file, close it, and then we will create our main.go file so we can execute our application. We will declare our package. Our main file in which we have a main function will be file which we will execute. Because of that, this file always must belong to main package. In our import section, we will import fmt package and the logrus package. Now, inside of our main function, we will create two objects, p1 and p2, where these objects will have data type of person with pointer, but we will create them in two different ways. p1 will be created by default writing. Second object, p2, will be created with constructor with our new function. Now, interesting thing is that how we got our person objects. In front of our person structure and in front of our new function, we can see person dot declaration. So this means that our structure and our function are called from our person package. How we can declare our package as our module so we can import that package inside of our main package. Let's see what is our zero module. When we created our module file, our zero module looked like this. So now that is the starting point for each module which we want to import in another package. So how we can import our person package inside of our main package? We will import our zero mod inside of our import section, and then to this zero mod we will attach specific path on which we can find our person package. If the last directory of our zero mod is mods, then we will type /model, and then inside of our model we have person directory, which means then we will write /person. Now we have specified location of our person module, which is created from our person package, inside of our main package, so we can use structures and functions from that specific package. Now we know from where we called our constructor with new function and from where we created new person structure. We can write if statement in which we can check if values of these two objects are same. If they are same, we can print message inside of our log that these objects are equal. After that, we can print whole objects of p1 and p2 variables. Let's now save our file and execute our main.go file inside of our terminal. Now we understood how we can separate specific code inside of different files and how we can import code from one package to another.